Hello, folks. Welcome to Rational Science. Not feeling too great today. I'm going to see how I can go through this whole thing. Got a problem with my legs. I have problems sitting. Unbelievable. Anyways, let's get on with the show. I'll talk a little bit about subject matter that I haven't touched in a while. Okay, and it comes at the heels of a little article I read about this gentleman, which I guess most of you, if not all of you, know. Okay, his name is Elon Musk, and he says we're quickly heading into a world where work will be unnecessary and money useless. My prediction is that work will be optional in 10 to 20 years. It'll be like playing sports or a video game or something like that. You can go to the store and just buy some vegetables, or you can grow your own vegetables, right? And that will be what work will be like, optional. Continued improvements in AI, that's where he's getting this idea, and robotics, right, suggests that money will stop being relevant at some point in the future. Currency becomes irrelevant. There's basically only one way to make everyone wealthy, and that is AI and robotics. AI and humanoid robots will actually eliminate poverty. That's his prediction, and that kind of got me started. For those of you who know what this site says about that, have been around for a while. Well, we say that what we have today, the humans we have today, we are the last generation of humans on Earth. That's what we say. There is absolutely no possibility of us making it to the 22nd century. I even doubt, perhaps, that we might not even make it to the year 2050. I think the collapse will happen before then. So what am I talking about? Have I gone to the future and come back and seen what happened? Am I Nostradamus, a seer, a prophet? No, it's got nothing to do with the future. It has to do solely with the past. Okay, extinction has to do with the past. And what am I talking about? I'm saying that what we're looking at is not a prediction. We're looking at an explanation. We're looking at the causes. What causes a mass extinction? What is the mechanism? And no one has discovered it in the last 200 years, 200 plus years, since George Cuvier, essentially the father of paleontology, ended up, creating this thing called paleontology. And nobody has figured it out, how species become extinct. You're talking about extraterrestrial impacts, which they already, had already brainstormed in those days, so that's nothing new. They're talking about climate change. They're talking about, the cycles, the oxygen, nitrogen, carbon cycles, etc. Plumes coming out of the ground, methane, egg predation, supernovas. They've got all these theories out there, none of which have anything to do with extinction. Extinction happens in one way and one way only, and happens always in the same way. Mass extinction. I'm talking about a mass extinction, right? Just to contrast it with background extinction. Mass extinction happens always in the same way, and it's always an economic collapse. That's what it is. Okay, it's always an economic collapse. What do I mean by that? Well, all animals do economics, all of them, in the wild. What are they? What is economics? It's management of resources. What resource do they manage? Food, primarily. 99% of it is food. That's what they manage. And when food goes away, guess what? The animals die. The animals who are dependent on those sources of food have nothing to eat, and they massively die. And it always happens to the old species that were around, and new ones continue. In other words, but you got to explain any theory of extinction. The only thing that they really have to explain, whoever is the theorist, is selectivity. How does Mother Nature select one over the other? And not only selectivity, but it has to explain chronological selectivity. How does Mother Nature only select the old species and leave the new ones alive? Not only in plants, but also in animals. That's the whole thing. And that's what you see throughout history. Okay? And here's some charts that give you an idea. Here's the mechanism I propose. It's the ecological pyramid overturn. Okay? And what it is you have a regular pyramid on your left. That's a healthy one. What happens towards the end is overturns. Okay, that's what it is. A mass extinction, disappearance of a food chain, specifically an old food chain. And what replaces it is the radiation of new species of plants and animals, little ones. They're at their feet. And once the big guys are out of the way, they take over the land and they begin the process all over again. Okay, that's essentially what we propose for a mass extinction, and that's what's going to cause the extinction of man. Here you see a picture of that just by glancing at it, you can get an idea of what happened throughout history, how it happened, why it happened, the causes. That's what we're interested in here. And here you see it. Just a very quick picture. You see what's happened in the Devonian and the Carboniferous, and you had these non-vascular, early vascular plants. They were essentially, they used spores. Okay, that's how primitive they were. And they were replaced by plants of the Permian and Triassic, primarily the seed ferns. In the Permian, you had the Glossopteridales, and in the Triassic, you had the Dicroidiums. And when those plants disappeared, the Glossopteridales disappeared in the Permian, guess what? The ancient mammal-like reptiles disappeared. When the dicroidiums disappeared in Triassic, guess what? The archosaurs disappeared. And what continued were these tiny animals that were waiting for these big guys to get out, and they were following a different type of plant. They were following the conifers, and they were known as the dinosaurs. We had different kinds of dinosaurs in the Jurassic and the Cretaceous, but essentially they were all conifer eaters. Okay? They ate gymnosperms. And what happened after the gymnosperms ran out? They were crowded out essentially by the angiosperms, but not only crowded out, they were also imploding. They were dying because of old age. They had been around for too long. Their genetic diversity decreased significantly. And so they were on their way out. And the dinosaurs were sitting on shrinking islands. That's essentially what happened. The jungles and the forests, they were becoming smaller and smaller of conifers, right? Were becoming smaller and smaller. And what was taking over the land were the angiosperms and the tiny little mammals that were following that new source of food. Okay, and that's where we are at today. And now what we have today is the same situation. The plants are going to disappear. The one that we all depend on. We have cows, we have chickens, we have pigs. There's millions of these animals that we deliberately raise because we have them in our market. It's a part of our business model. We sell them for eating. And all these other wild animals, there's very few of those. You have millions of cows, you have millions. I think the most numerous one are the chickens, right? And these animals, we feed them. We feed them for the market because we have some use for them. We eat them, etc. All the other animals, the wolves, the poor little wolf, the bears. There's very few of those. Okay, nobody cares about them. And tigers, lions. If they all died tomorrow, nobody would care. Nobody would notice. Okay, it's like the mammoth. When the mammoth died, nobody cared. Okay, it was gone. And so, we feed these animals, we keep them alive, and they all eat the same, more or less the same type of food we eat, which are angiosperms. And all we have to do is make sure that angiosperms are gone, and we're all gone. All the mammals are gone. That's how easy it is. And the question is, is that possible? Is it possible the angiosperms to die, to disappear? And the answer is yes. And it's because we grow the angiosperms that we eat, and also that these animals that we like also eat. And what happens when the economy falls apart? Because we grow them for money. And when the money disappears, when the economy falls apart, nobody produces these angiosperms or distributes them, and we all die. That's how simple it is. Okay, cities, they all depend on the country. Why do we produce food? For money. No money, no food. Just that simple. Okay, and so here you see the economic modes through the ages, and this gives you a pretty good picture of what's going to happen to us. This is our economics. Okay, and for 200, 300,000 years, maybe we were hunter-gatherers. About 10,000, maybe 15,000. You can take that as far as you want. Years ago, we went into farming. About 300 years ago, we went into manufacturing. The Industrial Revolution started in some countries. And about 30 years ago, we went into services. In other words, services were the main contributor to the economy, both in terms of labor as well as, GDP. And about 10 years ago, we went into special type of services, which are internet services. And what are internet services? Well, it's just entertainment and ads. And that's where we're at today. We're expanding that segment. And within that, we have the AIs, which are kicking people out of those jobs, and will continue to do so until, we reach full unemployment. Okay? And what does that mean? Well, it means that, our economy collapses. So one of the problems I've got with what Musk said is that he says the AIs are going to do everything. We're just going to sit around and we're going to loaf around. What problems do I have with that? Well, the first one is it's great to see it as an ideal society and say, okay, let's assume we go to another planet and find it already there. All the robots doing, the Jetsons kind of work. They do all this work, and we sit around and do nothing. Okay, we can more or less try to imagine that world. What is unimaginable, what Musk has not imagined, is that how do we get there? How do we get to 10% unemployment? How do we get to 20% unemployment? How do we get to 30% unemployment without the whole thing collapsing and going to hell? That's the issue. And so, we can always imagine the 100% society, 100% unemployment. We cannot imagine the 30% unemployment society. That's where the problem is. And that's one issue. The other issue is that we're not having children. We have no kids today. We stopped having children. The population of the world is still growing because, there's still people having children out there, but that's dying. Here's the growth rate that we have today. Gives you a picture of what's happening to the population as far as producing consumers especially, but producing children. And you can see that by the year maybe 2050, they think we're probably going to reach the zero population growth. In other words, the population of the Earth will stop growing. Humans, right, will stop growing. And I think it's going to happen a lot earlier. That's my green line there. That's my projection there. The projection right now is the other one, the red one. Okay, but you can see that it's been dropping. It's steadily dropping. There's nothing that you can do to turn this around. Okay, there's absolutely no way you can turn a population pyramid upside down ever again. Okay, here you have population through the ages. Okay, you can see what's happened. We were very few through most of our history. And just in the last 100, 200 years, you can see what's happened. It's just ballooned. Okay, we've gone all the way up. We've had lots of children. Okay, and we're still an empty planet, by the way. Okay, the problem is that we're all in the cities. That's the problem. So we're not going to be founding new cities. There's going to be no new cities out there. The Russians have all this land, and their population is imploding. Japanese don't have land, but their population is also imploding. You say, well, how can that be? Well, it is because everybody's in the city. And nobody's going to go out into the middle of Siberia and create a new city there, a new town, and, from there start growing again. The age of colonization is over. It's never going to happen again. And so all countries, even the United States, is in negative population growth. The only reason the United States is growing is because of immigration, nothing but. And the same for Europe. Europe, just about every country, in fact, I think every single country is in negative population growth. And so, yeah, we have a problem because we're not having kids. And on top of that, because of inbreeding that we've had for the last 300,000 years, we've married amongst ourselves. Because of inbreeding, we're having not only a loss of genetic diversity, but we're having all kinds of mental problems and physical problems today, which are genetically related. Okay, so here we have, here's the global population, the pyramid essentially, and you can see what's happening. More and more people are becoming older, and we're having fewer kids, and so the population is going to overturn. Okay, that's going to the population pyramid is going to overturn. Okay, and so yeah, we have a problem with that. If the population pyramid overturns, how do you overturn it again? And women and men, essentially both of them, don't want to have kids anymore. And why is that? Partly because of economics. But they're in the city. We're out in the city. We're urbanites now. We're no longer in the country. In the country, our great-grandmothers had 10 children. Half of them died. Didn't matter because, if you had 10 children, 5 of them survived to adulthood, you're okay. You still keep expanding. That's not happening. Right now, we're not having the children to begin with, and whoever we have has all kinds of problems, mental or physical. Most of them, or a lot of them do. A big percentage of them do. And so, yeah, the question is, where does this lead? And then you have some people out there who propose that, in fact, Musk is one of them. He proposes that we can go to Mars. He's a proponent of going to Mars. And here it is. See if I put him up here. He says the following. He says, becoming a multi-planet species. We're going to conquer the planets and maybe from there on move to another star. Right? And this is how I got involved in the topic of extinction because, and he said it was going to happen by 2024. He said that 8 years ago. But the prediction is not important. I mean, he could be off by a few years. That's no biggie. The problem is whether it has any chance at all whatsoever. And the issue is that I used to believe in the same thing. I used to believe, just without thinking too deeply in it, and that, yeah, we're going to conquer the planets, then we move to another star system, then we'll conquer the galaxy and so on. I thought that was the natural progression of humans. I said, yeah, we're going to make it all. It's going to be nice. I won't see it, but yeah, it's going to happen. And today I say, no way, it's impossible. It'll never happen. There's absolutely no possible way. And here you have one fellow. His name was Carl Sagan. I was a fan of him. I used to be a fan of him. I'm sorry I was. I think he was an irrational individual. He was a great teacher. I liked the way he taught and so on. That's what conquered my heart. But what he taught was garbage. All of what Carl Sagan ever said was trash, was nonsense. And that's why I stopped following him. And this is what he had to say about Mars. Let me put him up there and listen to him. Okay, hear it from the horse's mouth. Here it goes.
We would need to evolve by artificial selection and genetic engineering dark plants able to survive the severe Martian environment. We might even imagine a kind of Martian Johnny Appleseed, robot or human, roaming the frozen polar wastes in an endeavor which benefits only the generations to come. It might take hundreds or thousands of years. If the planet ever is terraformed, it'll be done by human beings whose permanent residence and planetary affiliation is Mars. The Martians will be us.
I had to put that in there. I couldn't resist it. Yeah, I think he was crazy, and unfortunately, I believed like he did at one time. And very embarrassed about that, but I do confess. No, we're not going to go to Mars to colonize or to conquer it or whatever. First of all, it takes many billions of dollars to get people out there, right? And that might still happen. You know, maybe they might send an expedition out there and you have a few astronauts walking the surface of Mars, taking pictures, collecting rocks or whatever they do, maybe trying to figure out if there's any life or there was life or whatever. That might happen. That's the best I can imagine happening. Whether it will happen or not, I don't know. An advantage is now governments are not as much in control of that project as much as individuals, rich people who fund these things. So that might happen because of that, because now you have private funding. Okay, so what do we get in return? I mean, if you're going to put money into a venture, what are you getting out of it? That's a question. And you can get technology. That's one possibility, right? Which at least would make the military very pleased. You know, suddenly you have this new technology that you might use against the enemy and so on. That's something you might look forward to. And you can stop there. That's about it. Well, also, you know, the fact that you created a craft, a ship that can make it all the way to Mars and back. Right. That's it. But, I mean, what are you getting out of it? It's not like you're putting money into something that's going to produce something. This doesn't produce anything other than that. Just technology and more technology. That's about it, you know. So what did Sagan say? Well, he said something that Musk, you know, just pulled from him. And it's this, that we're going to be a multi-planet species. Listen, Han, this is the ending. A few years later, right?
A remarkably diverse group of American leaders has endorsed the Mars goal. In the long run, the significance of such a mission is nothing less than the conversion of humanity into a multi-planet species.
And those are the exact words that Musk used. We're going to be a multi-planetary species. No, we're going to be a one-planet species. Believe me, it's third rock from the sun. Okay, we're never going to leave that. And what is funny, you know, he was also planning. Carl Sagan, he was planning on sending things out there to contact other civilizations. You know, said, hey, if we send a rocket out that goes out of the solar system, some civilization out there might see it, and they say, hey, you know, there are other humans or other intelligent beings somewhere in the galaxy or in the probably in the galaxy, because it would have to travel very, very far for some other galactic civilization to see us. It would have to be within our galaxy. And so they set this thing on one of the Voyagers, on two of the Voyagers, in fact. And it's a disk that has information about, you know, our world, a little bit of information. Whether they would be able to read it would be interesting. You know, I doubt they would. Okay. They had another one going to, what was it? The Pioneers. That one before the Voyagers. Okay. And that's what they sent out there. Okay, a metal plaque, again, because the probes were going to look at something in the solar system first, and then they were going to continue onwards, and they say, okay, if it's going to continue, why don't we just put something in there so that if someone ever finds it, they say, okay, there's a civilization out there, maybe they could find us. They try to put a picture of where we would be at, okay? And is that a waste of money, a waste of time? Because remember, to make these plaques and these discs, you have groups of people, and you have to pay them good money, you know, to do that. And they devise a little disc, and they put it on the ship, and the ship goes outwards, right? Message in a bottle. You're stuck on an island. You throw the bottle with a message, please find me, you know, help me. No, it's never going to happen. We're never going to be in contact with another civilization. It'll never happen. It's impossible to happen. So we shouldn't even try. And if we can reason that it's already irrational to even try, why spend the money in these groups that create these things, put them on a ship and send the ship outwards to contact another civilization? And I think some of the people in the government, in the U.S. government, are thinking those terms, and they say, hey, how much money are we spending on NASA and on some of these projects? What are we getting out of it? Are they going to produce anything? And that's why, I think that they're going to be cutting some of the funding from some of these projects. And I think they're doing the right thing. I think they should cut them all completely. We're not going to go out there, and so, it's just a waste of money. Taxpayers' money, that you're paying for that. And why aren't we going to reach another civilization? Why aren't we going to make contact? You have SETI, search for extraterrestrial intelligence. And I think they shouldn't go extraterrestrial intelligence. We should focus our microscope at SETI and find out if there's any intelligence there at SETI. Okay, and I don't think there's much intelligence in there. Why aren't we going to see another civilization? Why aren't we going to be in contact with one? We're never going to be contacted by one. We're never going to see one. Nobody's ever going to know we even existed once extinction takes effect. And we can start with Mars. Let's find out why Mars is a problem already. Why we're not even going to conquer Mars. We're not going to colonize Mars. We're not going to have people on Mars, create a civilization on Mars. Never going to happen. And here are the brute facts, okay? And here you have the Earth on the left. I hope you recognize that. And Mars on the right. Okay, you can see the diameters are a little bit different. The Earth is almost twice as big as Mars as far as the diameter is concerned. Volume is even bigger. You've got an order there different. One is 10 to the 12th. The other one is 10 to the 11th. Kilometers cubed, okay? Look at the mass, difference in mass, because again, you have one order there, 10 to the 24th versus 20 to the 23rd, and it reflects on the gravity. You can see right underneath it. And because of, the gravity is very different, that's something you got to take into consideration. The day is not important. They both have more or less the same day, so that's great. Years a little different because they're farther out, so it takes twice as long for Mars to go around the sun. Okay, no biggie there either, I think. Big problem not only is gravity, but atmosphere. You can see the atmospheres of these two planets are significantly different. And that's why Carl Sagan was talking about it might take hundreds of thousands of years. Why? Because they need to terraform Mars. In other words, they have to change the surface, the atmosphere of Mars, okay, to make it, suitable for us. O2 specifically, probably nitrogen as well, but O2 specifically, right? And that means you have to convert the CO2 into O2. That's a pretty big engineering project when you're talking about a whole planet, and the entire atmosphere. That's one issue. But assuming even if we grant that, let's say tomorrow morning we have the same atmosphere on planet Mars as we do here on Earth. The first problem is the pressure. We got a different pressure over there. Why? Because it's a smaller planet. We have a different gravity. So, all that air, it's going to go away. You're just going to have a thinner shell of air around the planet for us to breathe. So that's going to be a problem. I'm not sure you can cure that. But then again, it's, spending the money to get there. And the question is, are we going there to explore? Are we going over there to colonize? Are we going there to get rid of all the prisoners in our jails and say, hey, send them all out there? I mean, why would we do that when these people now are over there, right? Why would they even pay attention to us? Here we sent a group of people out there. Let's assume they multiply, which is already hard to believe in this day and age, right? So they start having kids after our genetic diversity has been wiped out completely almost. And then you have a small group of people from there that you're going to populate all of Mars, right? And again, their genetic diversity is going to expire in 2 or 3 generations. But assuming we get through all that, why would we do it? Why would we send people out there to Mars? They're far away. They lost contact with us. Are they going to send potatoes and sell them to us? Or are we going to have commerce with them? Is that what we're going to be doing? So many millions of miles away. I mean, I think it's cheaper to buy potatoes here. And I'm just giving just an example here, but things that you can produce here, there's no need to go to Mars to get it. And so there's no economic reason to put a colony there that would later on sever ties with the Earth. And on top of that, 2-3 generations later, their genetic diversity is gone and they're going to be producing kids with 6 fingers. So, no, it's never going to happen. And, here you are on Earth, right? And the question is whether you want to go from heaven to hell. I mean, is that a good deal? We're in heaven here in the blue planet, and we want to go to this red hellish planet. Yeah, sure. I'm not sure we want to do that. And so, again, I don't think we're going to be in contact with any civilization in great measure because, not so much because there aren't any. Of course there's got to be. In the universe, I'm sure there's got to be other intelligent beings. We'll call them humans, okay? Because I think that human is the highest level of intelligence that Father Universe, Mother Nature can make, can build, can construct, okay? So we are the highest intelligence there can be in the universe. Anything that's explained to us, I mean, if God Almighty himself came here tomorrow and explained something to us, we have the intelligence to understand what he's saying, okay? So we have the highest intelligence possible that all animals should envy from us. But so are there other intelligent beings like us? Very likely. But the problem here is that we can see, first of all, that life is very scarce in our solar system. It's all silicon. It's not carbon-based, right? Are there silicon beings? Well, I'll let you figure that out. I say there's no such monster as a silicon being, okay? But if there is a civilization out there, carbon-based, intelligent like us, they're very, very far away. And it's not so much the distance. The issue is time. We've only had, 200 years of, and I'm being generous here, right? 200 years of electricity where we have a telegraph, we can send signals out there into outer space and receive them and so on. Let's assume we've had this technology completely like we have today for 200 years, right? 200 years is nothing. In the timing of the universe, it's less than a drop of water in the ocean. That's what it is. And so we have staggering. If there are other civilizations, they either already went, they became extinct, or they haven't reached that level where it's 200 years. That's the whole window, right, before we become extinct. And so to find another civilization in our same level that can send signals to us, oh man, I like to see the statistics on that. That's got to be negligible. And I'd say it's impossible. It's simply not in the cards. We're never going to hear from anybody out there because of time. We're just staggered in time so much. Whoever evolves to the point that humans have evolved, not only are they far away, but they're distant in time. It doesn't happen at the same time as it happens to us. Maybe there are dinosaurs in another planet right now, and you say, well, we got to wait a few million years until we can communicate with them. Yeah, just sit and wait, right? No, it's not going to happen. And so, bottom line, no, we're due for extinction. And I'm just glossing over a lot of the fine detail here, okay? But I think we're due for extinction, and because of that, we're not going to be conquering any planets. We're not going to be hearing from other civilizations. And we should be getting ready for what's coming. And it's the end of man. That's what it is. Our economy is about to collapse. And there's nothing we can do about it. In fact, we have a lot of these bubbles out there right now. And they're all about to pop. We have the housing bubble. We have the stock bubble. There's several bubbles out there, investment, all that. And a lot of that is, I think, about the collapse. We have nothing new to expand into. There's no new line item in the economy where we can expand and put people to work again and so on. And so, again, when Musk says we're going to end up, without needing money, having the robots doing everything, yeah, it's a great dream. And the question is, how do you get there? That's one issue. The other one is, I don't think even if we got there, we wouldn't live for very long again, because, our population is going to be declining, and we have lost our genetic diversity, meaning that all the kids that will be born from such a society will be ever with bigger and bigger genetic problems. And that's how Mother Nature ensures that even the most intelligent species that she created goes extinct as well. Okay, let's get to, and by the way, I think that's an uplifting story that I just told. You say, hold it, what do you mean uplifting, Bill? You just told me we're all going to die. How can that be uplifting? I'll tell you why it's uplifting. It's uplifting. You should be cheering, you should be celebrating, getting your champagne bottle out. Why? Because look at all the problems you have. I mean, your wife left you, or if you're a woman, your boyfriend, went with another girl. You have a kid who's rebellious. You can't pay your debts. You can't find work. You got all these problems. Maybe you have health problems, right? You have all these problems. And suddenly I tell you, hey, don't worry about it. Because there's something worse. We're all going to become extinct. We're all going to die. That should cheer you up. Say, hey, I don't have such a bad life after all. That's the context there, okay? Okay, so let's get on with the subject matter today. And what am I going to talk about? Well, I'm going to talk about tachyons, right? And we'll get to that in a second, find out what those are about. But before we can get there, we got to look at, how much irrationality we have in physics today, in so-called physics, mathematical physics, which ain't physics at all. It's not even science. And what we have today is total irrationality. It's totally irrational, what we see in there. And here we have an idea of what that means. What do we mean mathematical physics or science is irrational today? And this is just a quick glance at it. The word irrational, what do we mean by irrational? Well, it's primarily that first one there. Treating concepts as physical objects and moving them around. Not defining words or using them inconsistently, using the definitions inconsistently throughout your dissertation. Theory is inconsistent with the assumptions. You make some assumptions. I always give the same example. I should change the example, but I think it's a good example anyways. The prosecutor presents a knife. He says, the victim died by, at the beginning of his presentation, he shows a knife. And then throughout the story, his presentation, his case, he says, the victim died of poisoning. Well, hold it. You presented a knife, he died of poisoning. I mean, one thing doesn't follow from the other. And that's essentially what we're saying there. When the theory doesn't follow from, the assumptions. The explanation from the assumptions. And then there you have the mechanism is unimaginable. And that's what we have today. We have only those four there. There's nothing outside of that, and that's why everything that you hear about, see today, or read about in the literature is all irrational. None of it survives rationality. None of it belongs to science, has nothing to do with physics, and nothing to do with reality. Here's the first one. Here's the first example. We've been covering it, graviton. And here you see the little graviton. It's supposedly a string, they called it. I call it a ring because what you see, it's a ring that's simply changing its shape. That's all it is. It's a ring. So it's not a string. A string would be maybe, an open ring. Okay. And the most famous one is this graviton, massless spin tube particle resulting from the vibration of a closed loop. That's what they have out there. And I've been covering that, 2 weeks ago approximately. And what is this string? You're saying, well, okay, there are these one-dimensional strings, and they vibrate, and that's what a particle is at the tiny level. Okay, maybe that's true. Is it true? Can it be true? Well, it can't be true. And here, let me tell you why. Here it is. This is what they are showing. They're showing a one-dimensional, they say, string, and what you're seeing really is the locations all around the ring. What they're doing is they're creating this with zero-dimensional locations or positions, as they call them. Okay, and so the ring itself is not like a ring that you would see, maybe at the kiddies park. Okay, what it is an itinerary around a closed-loop itinerary. That's what the famous string is. This is a better way of maybe illustrating what they're talking about. It's like that, okay? It's just a circle. All the points making it, and that's what the famous string theory is. It's an itinerary. It's not a thing. It doesn't look like this. Okay, this is a ring. Okay, fat one. 3D ring. They say it's a 1D ring, but what is 1D? 1D is an itinerary made of locations, and that's their famous ring, string, whatever they want to call it. Okay, and so we have a problem with what they're proposing. They're saying string theory is going to take over and be the new religion, and really it's not even worth even considering now. And here we have a fellow, his name is Brian Cox, and he's going to tell you that all these famous strings, rings, these gravitons that are made of strings, you know what? Why don't we see them? Why can't we touch them? Why can't we, how do we detect them? And he tells you very simple that you can't see them because they go off to a different dimension. Here, listen to him.
If gravitons are created, the reason why they would disappear is because they vanish into a place beyond our reality, into some sort of extra dimension. There can be extra, hidden, unseen dimensions. Gravitons, the particles of gravity, can spend most of their time in those extra dimensions.
So, not only do we have this ring made of points, right, which are, what they're talking about is an itinerary. That's the first problem. It's just a mathematical thingy there. They call it mathematical objects. That's the first problem. But then, to put it out of your reach, like saying, well, if you ask the question, what am we going to answer? They go out to another dimension and they fix the problem. Not only do they have an irrationality when they present their famous ring, but then they have a bigger irrational saying, well, they go to a different dimension. And so they put it out of your reach. And you say, is anyone studying all this stuff? Who cares about it? Yeah, you're paying for it. And here are the papers for strings that you see out there in the archive. Okay, all these papers, and I just pulled, a few of them there. 12? Just to show you that there are people investigating strings. Here are the people investigating gravitons. Okay, same thing. You can see that both of them are very popular subjects, and you're paying for this. These people are studying, rings and gravitons, and even if we concede that, we have a problem because what you have is that the graviton cannot be reconciled with gravity of general relativity. The graviton belongs to quantum mechanics, and okay, so it's a ring. Let's call it this one. Let's say it's a 3D ring, so that makes more sense, right? Even if you make this, okay, so what? How do you pull with a ring? How do rings pull on other rings on other rings? How do these vibrating particles, discrete particles, pull on other particles? And even if you were to solve that problem, what does that have to do with the explanation that general relativity gives to all this, which is the warping of number lines? 4 number lines, length, width, and height, they call them, and time, they call them number lines. Well, they're not, but That's what they are. In other words, they're not length, width, and height. That belongs to physics. What they have is mathematical number lines. They warp them, and they say that's the explanation for gravity. Okay, so the reason you fall downwards is because, you're warping space-time. You're warping the number lines underneath your feet. That's why when you fall, from a mountain or whatever, you're warping the number lines. What's that got to do with gravitons? Assuming, they finally figure the gravitons out as being strings, vibrating strings. So again, it's all irrational. None of that has anything to do with reality. It's all math, and they're developing equation for stuff that doesn't exist. Here's another one we covered. It's the wormhole, okay? And here it is. A fellow just says it, so-called physicist. The central reason for ongoing discussion of wormholes is their potential application in teleportation and time travel. There it is. That's what it is. They're talking about time travel. What do you mean time travel? Travel to where? You can't travel in time because there is no such thing as time. All you have is Father Universe. What is Father Universe? Every atom that comprises our universe. Every atom has location. It has a distance with respect to all other atoms. And that is Father Universe. Father Universe does not recognize time because for that he would have to recognize a previous frame in the movie. And that frame doesn't exist anymore because all those atoms have moved to where they are right now, in the present, the cross-section of time, which is location. Location is a static concept. It's a single frame in the film. There is no previous frame in the film, meaning there was one, it no longer is there. Why? Because all those atoms have moved to the new frame. And we call that the present, which is a wrong name for it, or the now, because those are wrong, because the present, it has to do with time, and time requires at least two frames. So you cannot have a slice of time. You can have a slice of location, of distance, that you can have, of existence. You cannot have a slice of motion. You cannot have a slice of time, because that's location. Okay, that's every atom in the universe at a given distance from all others. That's what you're talking about. And so, Father Universe does not recognize time, so talking about time is really a waste of time. That's what it is. Okay, so here we have black hole is the mouth of one of these wormholes, okay, that these people are studying. They develop equations for this stuff, and they say, it's the mouth of a wormhole. Great. So now we have not only that, we go into the past, because that's what they created these mathematical concepts for, but now the mouth of it is the black hole. So you jump into a black hole, and I've shown this in the past, but here's good old Brian Greene. He's going to jump into a black hole. He's going to shake hands with himself in the morning. So he jumps into this black hole, which is the entrance to a wormhole that takes him to the past, which is himself in the morning. Okay, he shakes hands with himself. Okay, so is this science? Is this what science is all about? It doesn't get any better than this. Okay, we have a problem because these people are talking about nonsense. They're developing equations for stuff that has no chance of existing. It's just fantasy. It's not even fantasy. I don't even know what to call it, because it's all total irrationality. And if they want to write a book and sell it to Hollywood and make a movie out of it, that's fine, no problem. But for them to use this and say this is science, this is physics, this is reality, absolutely not. This is absolute nonsense. Okay, and so here we have a paper that just came out. Says a mathematician thinks black holes could be cut and pasted to form a wormhole. So you have two black holes, right? The mouth, right? Remember, black hole is zero-dimensional. There's nothing there. Okay, so there ain't any black hole, because the black hole is made out of a singularity surrounded by an event horizon. And what are we talking about? Well, we're talking about two concepts. Two concepts do not an object make. I can't put love and intelligence together and create a rock, which is what they're saying. They're saying it's an object. No, it's not an object. But that's what they say. It's a concept. It's a concept that they turned into an object. They say it's the entrance to a black hole, to a wormhole. Okay, so we have the wormhole is now you have these two flat surfaces together. In fact, I tried to illustrate that the other day. Here it is. The famous wormhole that you see on the top, that's the one they always illustrate. They should illustrate it like the one on the bottom, with the two faces facing each other, which is what this guy is talking about. Okay? So the famous wormhole should really be face to face, because that's the only way you can cross the wormhole. 1 second later, you're, a million years into the past. How did you do that? You couldn't have traveled across the universe. No, you had to cross some kind of, like crossing a door or a curtain. And on the other side, you're already in the past. That's how fast it is. And so it's got to be face to face, black hole to black hole. Okay? And so they have all these idiotic concepts because they're talking about traveling to the past, seeing their grandfathers and who knows what. Or even to the future, because it's the same thing. There's no difference, really, whether they go to the past or the future. It doesn't exist. There's nothing there. We exist only in the present, meaning in a cross-section of time, meaning location. All we have is distance from every atom in the universe to every atom in your body. That's our universe. And anything before or after doesn't exist, except in our minds, in our memory. Okay, so... they talk about traveling, waves, gravitational waves coming through a wormhole. Paper just came out. Scientists think mysterious signal may have come through a wormhole. They're talking about you have a 1D line, right? And they say that a wave is going through that 1D line. That's the collision of these two black holes they found some time back. They say it was really not a collision between two black holes. The gravitational waves really came from a different universe, and it came through a wormhole. I mean, how much idiocy do you want to see in mathematics? This is total nonsense. It's got nothing to do with anything with reality, and they're developing equations for this stuff. And you're paying for it. You're investing it. That's the weird part of it. You say, well, is that true? Yeah. These are all the papers that you'll find, not all of them, but I mean, I pulled up a whole bunch of papers again in the archive of people who write about wormholes. And they're developing equations for this nonsense. And you're saying, is this what we're paying for? We're paying for what? Black holes? We're paying for wormholes? We're paying for gravitons? This is what these people are working on? Well, they might as well, work for equations for, angels going to heaven or souls going to hell. I don't know, leprechauns, unicorns. I mean, they're working on stuff that doesn't exist, that has no chance of existing. It's all just math on top of math on top of math. They say, oh, I know calculus. What can I do now? What work can I do now? Oh, I know, I'll work on something like a wormhole. And the other guy says, well, I'll work on gravitons. And the other guy says, well, I'll work on black holes or dark matter, stuff that doesn't exist. And you're paying for it. And you say, okay, what are you working on? I'm working on black holes. What are you doing? Developing equations for a black hole. There's no such thing as a black hole because a thing has to have shape, and a black hole is zero-dimensional. We have a singularity that is a mathematical concept that means infinity. That's all it means. And it's surrounded by another concept called the event horizon. There's nothing there. So far, you have nothing. You're developing equations for nothing, literally. Okay. Then we have the famous dark matter. They're looking for this stuff, and what is that dark matter? Well, it's the stuff that surrounds a galaxy, allegedly. And it's always like the black holes and the wormholes, all these other things, virtual particles, etc. They're all conveniently invisible and intangible. People laugh when I say that the rope that I propose is invisible and intangible. And they say, oh, I'm doing, supernatural stuff, irrational stuff. These people are working exactly on the same thing, working on invisible, intangible stuff. Black holes are invisible and intangible. Dark matter is invisible and intangible. So is, a virtual particle. All these things are invisible and intangible. Nobody says anything about it. And these people are developing equations for this non-existent stuff. Okay? And there you see it. It says that it's only about 15% is the ordinary matter that makes up the planets and people that you see in the universe. The rest is all either dark matter or dark energy. And this is what they spend their your hard money on spending it on developing equations for this inexistent stuff, because they truly believe that it's out there, that it surrounds the galaxy and keeps the galaxy, the stars on the outside, especially of a galaxy, moving fast or faster than the ones on the inside. That's what they do. And so you have people who say, well, what could all that dark matter be? And these guys come up and they say, they must be WIMPs. What's a WIMP? WIMP is a weakly interacting particle, massive particle, they say. Just concepts that they invent. The WIMPs are just as invisible as the dark matter to tell me that the dark matter is made of WIMPs. We haven't solved anything. We just created another concept. We could have said it's made out of X and X is made out of Y. We're not learning anything by that. We need to find out, what causes gravity. And these people say, we don't know. What we're doing is developing equations for stuff we think is out there. And it's all irrational stuff, because even if we were to concede all those particles that you see there, okay, let's concede it. How do those particles produce the effect of gravity? And what you're seeing is not particles. Those particles really represent values. They represent kilograms, because that's what they put in the equation. They say, if we have so much mass, we can produce that same effect. And so they only talk about mass, and that's what the dark matter is. It's dark mass. It's just mass that they put in there in an equation. It's kilograms. That's all it is. That's why they can't see it. It's very hard to see a kilogram. I've never seen one. I hope you have. So yeah, or pounds. Never seen pounds or kilograms. And that's what these people are dealing with. They call them particles. They call it matter. And it gives you the impression that they're talking about something real when they're not. They're talking about concepts, mathematical concepts. And so here's, they had to introduce this as well, the fifth dimension, because at some point they get into this, what I call dementia, plural, right? Dimension, plural is dementia. And here it is. The answer to physics dark matter problem could lie in the fifth dimension. And they go through all this stuff and they analyze it and they develop equations for this stuff. And so the question is, what does this have to do with physics? What does this have to do with reality? What are we paying for? What are these people working on? They're just, making equations for the sake of equations to say, hey, I know how to do these equations as sophisticated calculus. And they apply it to what? To angels and souls and stuff that doesn't exist. And so this, it should shock you what mathematical physics has become. They're working on inexistent stuff, on stuff that has no chance of having anything to do with science or with physics or reality. And of course, you have the famous virtual particles. Okay, here you have all these virtual particles. Where are they? Well, theoretical transient particle that allows it to spontaneously emerge from the vacuum. So they have these particles that pop in from the void and they instantly go out, out of existence. So they pop into existence, they pop out of existence. And what are they talking about? They're talking about stuff that they need to make the equations come out right. They say, look, we had an observation. Something happened. We cannot explain it with just the ordinary stuff that we can see or detect with our instruments. So there's something else going on, and we're going to call that a virtual particle. It just popped in to make our equation come out right so that we can put that number, that value, whether it's mass or charge or whatever, we can put that in an equation. And what happens next? Well, now you get a Nobel Prize because you invented the virtual particle. I mean, what is this? They're inventing ghosts. They're developing equations on ghosts, on stuff that they just create out of nowhere. And they say, well, we couldn't measure it because it just came into existence very fast and went out of existence immediately. And so we know it's there because we need to have our equations, come out right. And so they put it in by hand, and then they invent a name for it. And they say, let's call it X. Oh, no, let's not call it X. X is a very bad. Let's call it virtual particle. And that's what they do. That's all they're doing. And here's a definition of virtual particle. A concept of, I like it because they say it's a concept. It's not a thing. It's the concept of virtual particle arises in quantum field theory, where interaction between ordinary particles are described in terms of what? Exchanges of virtual particles. So they had to create these terms, these non-existent thingies. They're really concept, mathematical concept. They give it a name. They say it's a virtual particle. And whenever you see the word particle, you know it's not a particle. It's not a particle. For the last 100 years, it hasn't been a particle. Particle is a ball. This is a particle. Okay, that's what everybody thinks when they hear the word particle. And they use the word particle, and it's very misleading because everybody thinks, okay, I know what a particle is. No, you don't. It's a number. It's a value. That's what it is. That's what a particle is, just a value. And of course, it's always zero-dimensional, right? Or not one-dimensional because that would be a line, but it's zero-dimensional because they don't care about the structure. They don't care about the size of it, volume, any of that. They just care about charge, mass, and some other characteristics. And that's it, or their field or whatever, right? So the issue is, they're not talking about particles. And they're saying it's a virtual particle. So now not only do you have this number, but this number comes in from the void to fix their equation, then it goes out again. So they're not talking about something that they can measure because there's nothing there to measure. It's just the religion of mathematical physics, which says that if we don't have that particle, we cannot, get that equation right. And so in order for the equation to match, to be both sides of the equal sign, we need to put this extra factor in there, this variable, and that's what they give names to: dark matter, virtual particle, whatever. It doesn't matter. And is anyone studying all this stuff? Well, yeah, sure. Here's the archive again. You see all the people studying different aspects of virtual particles. So it's not like, I'm inventing this stuff. No, this is for real. These guys are investing their time developing equations for all this stuff. They're developing equations for black holes, for dark matter, for the graviton, for wormholes, and for virtual particles. This is the bread and butter of mathematical physics today. So they have all these ghosts and goblins out there, and they're developing equations for it. They're all invisible and intangible, conveniently invisible and intangible, and they just develop equations. They're saying, I'm going to do an equation for virtual particles. What does that give us? What does that tell us about the universe? In what way does that help us? And so we have a problem because these people are just, spending their time developing equations for inexistent, non-existent, impossibly existent. It's just not happening. It's got nothing to do with physics, nothing to do with science. What are these people doing? What are they wasting your time? What did they study 10 years at the university for? Math, to use to apply their math, their equations, their knowledge of calculus for this nonsense, for all these inexistent stuff, these ghosts. Here's another one. This is the neutrino. And it says, giant Chinese, this one came out the other day, giant Chinese orb detects ghost particle. Yeah, I guess that's what they are, ghost particles, because they're not particles, they're just ghosts. While buried under mountain. What are they talking about? They're talking about these neutrinos. And what do they say about the neutrinos? Well, the only way they interact weakly with matter. That's the way they put it. Meaning, it's not there, it's a ghost, okay? And they say, well, move the curtain a little bit, so there's got to be a ghost there, okay? And that's the way they handle it. And they say, to catch one of these ghosts, we got to go underneath the ground. And out of 1 million neutrinos that come to underneath the ground, we might be able to detect one of them because that one reacted or contacted or had an interaction with actual matter. That's what they're hoping for. And so whenever there's a disturbance of some kind, they say, oh, we detected the neutrino, and they publish and they get a Nobel Prize. That's what they do. They say, we discovered it. We found it. We found a neutrino. Did you see it? Can you tell us what it looks like? Can you draw it? No. They just said, we detected something, and it's got to be a neutrino because of the mass, the charge, whatever. And that's the way they're handling all this stuff. So they're working on stuff that doesn't exist. Here's the neutrino equation, okay? Says that, Wolfgang Pauli came up with this stuff, and Enrico Fermi dubbed it, gave it a name. And what is it? In beta decay, a neutrino transforms into a proton, an electron, and an antineutrino. So they created these monsters because they said we cannot account for that extra factor. And if we have the law of conservation of energy, there has to be something there. And they call that unknown, that variable, that factor, and they give it a name. In this case, it's called the neutrino. Great. So we fixed the problem. So now we have a reaction. We have an equation, right? An equation that explains the reaction. We can now explain. There's another factor, and we call that extra factor a neutrino. And then they tell the guys out there, go look for it. It's invisible and intangible, interacts weakly with matter, but go look for it. And here's one that came out the other day. This one should shock your socks out of your feet. Okay, here it is. And it's that, what would happen if a tiny black hole passed through your body? This is what these people are studying. This is what they're developing equations for. They have nothing else to do, and they say, well, what if? What if what? What if a black hole went through your stomach and you ate one or whatever? And I don't care what the guy says, but this is what they're developing equations for. It should shock you. It should. I mean, if this doesn't make you wake up that something is totally wrong, not forget a little bit, but totally wrong, totally irrational, has nothing to do with reality. Well, I don't know what does then. And you've been suckered into this and you really believe on the basis of authority, or who knows why. Maybe you're just as irrational as they are. No, none of this has anything to do with anything. None of this has anything to do with science, with physics, with reality. They're developing equations for inexistent stuff. That's what they have. And of course, we come to the famous tachyon. What is a tachyon? I hate to tell you what a tachyon is. Let's start with this fellow. His name was James Maxwell. And what was it? In 1865, he wrote a paper and he proved, we call it, he just described, right? He described that light travels at 300,000 kilometers per second. We're done. Okay? We got the speed of light, which was already suspected to be more or less constant. He proved it with his equation there. Okay, no problem. Good, great. Now we know, we have a description. We don't know what light is because Maxwell never figured out what light is. The only thing I liked about Maxwell is that he said it's got to be something. There's got to be a physical entity underlying, light. That's as far as he went, but he didn't have any idea. And they talked about waves, and he talked about the ether. Okay, and what was the wave? The wave was the waving of the ether. Well, you had a couple guys, Michelson and Morley, and they ran a couple experiments, and eventually they came out to the conclusion that there is no ether, or at least that's what most mathematical physicists in those days, in the 19th century, that's the conclusion they reached, that apparently the test that they ran proved to them, suggested to them, any way you want to look at it, that there is no ether. There is no environment, no gazillions of particles out there that are vibrating. That's what the ether was, essentially. That's what they always thought. Some said it's a fluid, some said it's static. They had all these different versions. But essentially they thought of them as a bunch of particles forming a background. And that light was somehow the vibration of that ether or something moving through the ether or something along those lines. So they had all these ideas, but they never really pinpointed what is light, what is the mediator of light, right? They never figured that out. And about the same time, we had this fellow, his name is Waldemar Voigt, German guy, and he comes up with this factor. For some reason, they stole it from him because even though he's the first one that I can see so far, right, that he's the first one to come up with this factor, he's never given credit for it. Einstein's given credit for this. Lorentz also worked on it, but it's like even Lorentz has been brushed aside. Einstein's given credit for this. And they use this factor essentially to create what is known as special relativity. Okay? And so we have the speed of light, we have special relativity, and then you had all these celebrities, and there's several of these guys, okay? You have Albert Michelson and Morley there, Waldemar Voigt, and you have Oliver Heaviside. He's one of the guys who proposes that maybe the Michelson-Morley experiment did not really prove the inexistence of the ether because he still believed in the ether. He says maybe, when you have the light beam or whatever, it gets squashed in the direction of motion. That was his conclusion. And you have people like George Fitzgerald and let me get this in there better. There we go. And Lawrence, and they come up with equations that eventually, they say they created the foundations for relativity, what is known as special relativity. And it's Henri Poincaré who eventually comes up with this notion of what is known as special relativity. And all this eventually was given to Albert Einstein. He's the guy who got credit for all this, but it's all these people who developed all this stuff, really. Einstein kind of took the credit for a lot of stuff that he did not do, that he just borrowed from them, maybe modified a little bit. There's a debate on all that stuff. And then you have Minkowski. He's the guy who comes up with space-time. It wasn't Einstein. Minkowski wrote his paper, I think, in 1911 or 1912 on space-time. And so he said that from now on, there's not going to be just the three dimensions of space. You have to unify it. You have to merge it with time. We cannot live without space-time. Who was he talking about? The mathematicians, because they had to describe the point, the location of an event. And so they said, well, we need space and time. We need to include time there. We need to know what time it happened as well. And so he's the guy who created space-time. And Albert Einstein took the credit for all that, essentially. But, again, I'm not getting involved in that. There's a discussion on how much Einstein contributed and how much the other guys contributed. Everybody knows the name of Einstein. If you ask the person on the street if they know any of these other fellows, they'll say no, they don't. And so Einstein got the credit for all of it, essentially. And I'm sure he did not work in a vacuum. He did read papers out there. He built on other people's theories. And, today he gets the credit for all of it. And the interesting part is he gets credit for stuff that he did not do, but he's credited for stuff he didn't believe in. Einstein did not believe in black holes. He did not believe in Big Bang. He did not believe in gravity waves. He did not believe in a lot of that stuff, and even today he's given credit. Not directly, like, they always mention him, like, if it wasn't for Einstein, we wouldn't have this, but they don't say anything more, and people get the idea, oh, Einstein is the guy who proposed all this stuff. No, Einstein was against all that stuff. He wrote papers against them, but he gets credit for that he did not believe in, but he also gets credit for stuff he didn't do. So that's the way this world works. Anyways, the point here is that they developed special relativity, and what the special relativity says. Well, eventually they concluded that nothing can travel faster than light. But there are two versions of that you have to be careful about, and that's where the contribution of Einstein is being fought over. And that is, one thing is for you to measure light that's already passing by and say, well, how fast is this light passing through me or by me? Right? You measure that, say, at 300,000 kilometers per second. That's one thing. Another thing is when you look at the source and you say, well, hold it, the source is now moving. Should I add the speed of the source to the speed of light? That's a separate issue. And so, Einstein showed, I think it was him, I don't know if that's true either, because as I understand it, Poincaré also worked on that as well. And the question is that, you don't add the speed of the object that is emitting the light. The train goes at a certain speed and light comes out of the train. You don't add the speed of the train to the light. Light will always travel at 300,000 kilometers per second. And so that's interesting. How do you explain that from a physical point of view? And Einstein never explained it. He described it mathematically, but he did not explain it. Okay, so the issue here is special relativity says the speed of light is 300,000 kilometers per second, according to Maxwell's equation, according to the equations of special relativity. All of special relativity is based on the constant speed of light, one, and the other one, that speed of light is the maximum speed of the universe. Nothing can travel faster than light until we get to the tachyon. Okay, and so what is a tachyon? What do you mean a tachyon? travels faster than light. I thought we proved special relativity. I thought special relativity proved and, set as a firm fact that the speed of light is the maximum speed limit and it's a constant. And these people say, well, not really. Tachyon, a hypothetical particle that always travels faster than light. And there you see it, that's blue. Tachyon is always blue. The photon is always red, so now you know, okay? Yeah, for some reason they say that the tachyon travels faster than the photon. And you say, well, hold it. Doesn't this contradict, special relativity? Right there we have a contradiction. That should already bring it to your attention that, hold it, what do you mean? I thought special relativity proved the speed of light was the fastest thing in the universe. Now you're saying there's something even faster than the speed of thought, I think, and I'm there. And so how did this come about? Well, here you have the two individuals who proposed it, two groups, really. First one was 62. This group of three guys suggested a way superluminal particles, now known as tachyons, might exist without conflicting with Einstein's ban on faster than light speeds, provided they had what? Such speeds from the moment of their creation. In other words, if the particle was created already at a great speed, at a superluminal speed, then it's okay. Then they can exist. They cannot be created, by an object that sends it out. It's got to be created somehow by God, I guess, in such a way that it's already got that speed. And then this other fellow who came out, he's the guy who's going to give the name to the tachyon. He said after the work by these fellows in 62, it was Gerald Feinberg who later in a classical paper coined the term tachyon and proposed that tachyonic particles could be made from what? Excitations of a quantum field with what? Imaginary mass. It has to have imaginary mass. So today we have, what do we have? We have imaginary time, we have imaginary energy, and now we have imaginary mass. We have to have all these imaginary things on which they're developing equations, right, in order to work on tachyons. And what is the tachyon? A faster than light particle that goes against special relativity. And so they had to find a way to incorporate it because otherwise they'd be out of a job. They have nothing else to do calculations on. They have nothing to apply their calculus and their math on. And so they said, well, what can we invent? Well, let's invent tachyons that go faster than light. But that's forbidden by special relativity. No problem. We'll just invent negative mass and negative energy and negative time and who knows what negative other stuff they invented, or irrational or imaginary or whatever they call it. Okay, and so here you have the AI. I consulted the AI to find out, what do they have to say about the tachyons. It says papers on tachyons explore what? Their hypothetical existence. Hypothetical existence. I mean, they don't exist. But these people are saying, well, hypothetically, maybe they do exist because it helps us do the math on it. I can work something out with calculus if I just put more speed than light. So you take the photon, and instead of putting a value for 300,000 kilometers per second, you put a much higher number, the number you want, the speed of thought, infinite, whatever you want, and you call it a tachyon instead. And now you put that in your equation, and with that, it affects some of your other variables, and now you have to make your energy negative, your time negative, or imaginary, or mass has to be imaginary, or exotic matter, as they call it. They have all these variations of stuff they created. They had to do that in order to compensate for the extra speed of the tachyon. So this recent work often focuses on whether a consistent physical theory or tachyons is possible, with some papers concluding that they lend to unphysical results. No kidding. In other words, it has nothing to do with physics, like violations of causality and unitarity. Okay, so yeah, you have a problem with causality because now the particle ends up coming from the future. That's how fast it went. Okay, and they have all this all this stuff that they had to create, all this nonsense they had to create that has nothing to do with reality. And what are some of the problems? Well, this is according to the AI again. Fortunately, we have that. It says causality violation. A major theoretical obstacle is that tachyons, by definition, travel faster than light. Yeah, this would allow them to send information to the past, lending to paradoxes that violate the principle of causality. Yeah, so we have a problem there already. Unphysical results. Many theoretical models of tachyons fail when tested, either by producing results that are not physically consistent or by failing to satisfy key requirements of quantum mechanics like unitarity. And then exotic properties, what are they? Despite the challenges, researchers continue to explore their theoretical properties. Why? I mean, why would they explore if it's nonsense? It's not. It doesn't exist. Why would anyone spend a nickel of their time, right? Time is money, right? Why would they spend any time on this at all? Such as their mass, imaginary mass, and how they might interact with other particles if they did exist. So they create a nonsense that doesn't exist to have something to do, to say, well, I want to do some calculus. Okay, what do I do with that? I'm going to invent something. Okay, I'm going to invent something that travels faster than light. Yeah, but special relativity forbids it. So what? I'll do it anyways. I'll make an assumption. I'll hypothesize it, and then that forces them to have negative mass, negative matter, or exotic matter, negative energy, imaginary time, whatever nonsense they come up with. They have to change some other factor, and they get these papers published. That's the worst part. Here are the papers for good old tachyons. I mean, is anybody investigating tachyons? Of course they are. Lots of people are dedicating their time, their money, in other words, your money, and spending their time doing calculus and calculations for all of this nonsense. How's that? I mean, this is the world we live in as far as mathematical physics is concerned. And you should be concerned. Really, you should be. I mean, if this doesn't concern you, well, I don't know. Something is wrong. Because all this is irrational. They're wasting time on absolute nonsense that doesn't exist. And so that's all I can say. It's up to you to think about that. Tachyons, no, they don't exist. There's no such monster. There's no such monster as black holes. No such monster as dark matter. No such monster as wormholes. It's all garbage that they created in order to give themselves something to do, to apply their calculus that they learned for 10 years at a university. Otherwise, they would have nothing to do. And that's it. I'm going to open the floor up for questions. Anyone who wants to ask questions, go ahead. I'll give you 10 seconds. Because that's how long it takes for the transmission to get to you and for me to get it back. So I'll just wait a few seconds here. Okay. Yeah. Well, anyways, if anyone does have questions, they are welcome to put it in the comments section, and we'll address it either directly or next week in